The map of our world is about to change. And I'm not talking about China breaching boundaries. I'm talking about the continent of Africa splitting into two.
Beneath Africa, a remarkable transformation is quietly unfolding, one that is reshaping our planet's geography. The continent is splitting, with a massive crack forming in the Earth's crust. Recently, Elon Musk reignited global interest in this phenomenon, known as the East African Rift, describing it as one of the most significant planetary shifts in modern history. This rift offers a real-time glimpse into Earth's evolutionary processes. But why is Africa breaking apart, and what opportunities, risks, and mysteries accompany this phenomenon? Join us as we explore the science behind the East African Rift. In 2005, a team of geologists led by Dr. Tim Wright from the University of Leeds made a groundbreaking observation: a massive rift stretching thousands of kilometers across East Africa. This rift opened across multiple countries, even splitting a man's house in two. 2 decades later, it's clear that Africa is undergoing a continental rift. The East African Rift has since become a focal point for global geological research, with satellite-based interferometric synthetic aperture radar, INSAR, providing precise evidence of active tectonic plate divergence. This marked a pivotal moment in understanding how continents break apart. The discoveries within the rift are astonishing. Despite its significance, this phenomenon remained relatively unknown to the public until Elon Musk highlighted it. Musk emphasized that the rift is not a random event, but a visible manifestation of tectonic plates gradually drifting apart over 25 million years. These movements have shaped continents, oceans, and ecosystems. However, what's happening in Africa today is extraordinary, a dynamic transformation unfolding before our eyes. The question on many minds is, what triggered this tectonic activity? The answer lies deep beneath the Earth's surface. At the core of this phenomenon are the Somali and Nubian tectonic plates. The Somali plate, situated to the east of the rift, is gradually moving away from the larger Nubian plate. This slow movement builds tension within the lithosphere, leading to the formation of cracks, fissures, and rift valleys. Adding to this process are mantle plumes, columns of hot magma rising from deep within the Earth's lithosphere that help push the plates apart. These massive tectonic plates rest on a molten, semi-fluid layer called the asthenosphere and are propelled by heat and dynamic forces originating from Earth's core. The East African Rift is a classic example of a divergent boundary where tectonic plates move apart. As the plates separate, magma ascends from the mantle, resulting in volcanic activity, the creation of new crust, and the gradual splitting of landmasses. NASA has been instrumental in monitoring this geological transformation, employing satellite imagery and geophysical data to uncover hidden features. Advanced technologies like AI and machine learning are enhancing data analysis, enabling scientists to detect patterns and predict future developments with greater precision. One of the most significant advancements in this field is the use of geothermal sensors to monitor volcanic and tectonic activity. By tracking changes in temperature and gas emissions, researchers have been able to map the rift in remarkable detail. The East African Rift system stretches from the FR Triangle in northeastern Africa through Ethiopia, Kenya, Tanzania, and beyond. In some areas, it is visible as a massive crack in the earth, while in others, it appears as volcanic ridges or deep lakes. The FR Triangle, where the Arabian, Somali, and Nubian plates meet, is one of the most tectonically active regions on the planet. Over millions of years, this region is expected to give rise to a new ocean, eventually splitting eastern Africa from the rest of the continent. This phenomenon offers even more fascinating insights. It mirrors events from millions of years ago when Earth's continents first formed. At that time, the planet consisted of a single massive supercontinent known as Pangaea. Around 200 million years ago, tectonic plate movements began breaking Pangaea apart into distinct plates. As these plates drifted apart, they gave rise to the modern oceans, continents, and islands we recognize today. This process was driven by mantle convection, where heat from Earth's core caused the lithosphere to fracture and shift. The breakup of Pangaea had a profound and lasting impact, shaping Earth's current topography, including features like Africa's Great Rift Valley. Tectonic activity remains a key force in Earth's evolution, continuously forming and reshaping rifts, valleys, and seas. The African rift, for instance, is still in its early stages compared to older systems like the Atlantic Ocean. These features provide valuable insight into Earth's dynamic geology and its future landscapes. Significant rift systems are found worldwide. The Mid-Atlantic Ridge, a submerged boundary between diverging tectonic plates, exemplifies oceanic rifting in action. Similarly, the Baikal Rift Zone in Siberia showcases continental rifting in a colder climate. Both regions illustrate how rifting influences ecosystems, geology, and hydrology on a large scale, making the African rift an invaluable point of comparison. From the breakup of Pangaea to the formation of rift valleys and lakes, Africa's Rift Valley serves as a living laboratory for studying tectonic forces and their global effects. The African rift's current and future impacts are profound. Beyond being a geological marvel, it has significant geopolitical and economic implications. As tectonic activity progresses, a new ocean may form, reshaping Africa's geography. This could lead to the creation of new coastlines and provide maritime access to currently landlocked nations like Uganda, Ethiopia, Rwanda, and Burundi. Such changes could unlock economic opportunities, but they would require significant investment in infrastructure, trade routes, and governance to manage new borders and territorial waters effectively. The potential for expanded trade networks is immense, with a new ocean enabling faster, more efficient transportation of goods and boosting regional commerce under trade agreements. Additionally, rifting regions may become hotspots for mineral and energy exploration. For example, the Rift Valley is already rich in geothermal resources, particularly in Kenya and Ethiopia, which could be further developed to drive industrial growth and enhance energy security in the region. Despite its promise, the Rift Valley also presents significant challenges. Disputes over newly formed coastlines and resource allocation could escalate tensions, particularly in politically unstable regions. Realizing the rift's economic potential without igniting national conflicts will require careful strategic planning and international collaboration. Moreover, the rift's impact on the climate is not entirely favorable. Volcanic activity in the region releases substantial amounts of greenhouse gases, including carbon dioxide and methane, into the atmosphere. While these emissions are part of the Earth's natural carbon cycle, they could exacerbate global warming, if not counterbalanced by other processes. Another pressing concern is the environmental and human toll of the rift's ongoing tectonic activity. Rising water levels in rift lakes, such as Lake Baringo and Lake Bogoria, are already displacing communities, submerging homes, and destroying farmland. Additionally, volcanic activity and earthquakes, common in rifting zones, pose significant risks to human life and infrastructure. For example, the 2021 eruption of the Nyiragongo volcano in the Albertine Rift displaced tens of thousands of people. The socioeconomic conditions in the Rift Valley amplify these challenges. The region hosts some of Africa's poorest populations, struggling with limited access to healthcare, education, and infrastructure. Malnutrition and poverty are widespread, especially in rural areas where environmental changes caused by tectonic activity disrupt farming. Without targeted interventions, the consequences of rifting could exacerbate these issues, making adaptation even more difficult for affected communities. On the flip side, the rift offers opportunities for sustainable development. By harnessing geothermal energy, the region could reduce reliance on fossil fuels while expanding energy access to underserved areas. Countries such as Kenya, Ethiopia, and Djibouti have already taken steps to capitalize on this potential. Since its discovery in 2005, Kenya has quickly emerged as a leader in geothermal energy development, leveraging the geothermal potential of the Rift Valley. The Olkaria geothermal power station alone contributes over 900 megawatts to the national grid. Similarly, Ethiopia has initiated geothermal projects like the Korbeti geothermal plant, which aims to generate up to 500 megawatts. These efforts are bolstered by international collaborations, including the United Nations Environment Programme initiative promoting geothermal energy across Africa. One of the key advantages of geothermal energy is its renewable nature. It emits significantly fewer greenhouse gases compared to fossil fuels, making it a crucial tool for combating climate change while expanding energy access. Geothermal energy also helps reduce Africa's dependence on non-renewable sources like coal and oil, which are not only polluting but also subject to price fluctuations. By diversifying its energy portfolio, Africa can enhance energy security and stabilize costs.